Hello everyone, thank you for joining today's video. In today's demo, we will learn about Atom Active Service Assurance feature and how it can be utilized to run various network tests such as DNS, ICMP, HTTP, or combination of tests like TWAMP or 5G network suite test to maintain network SLAs and ensure all the critical network services like your VPN services or any other service are always up and running efficiently. Internet service providers spend a vast amount of resources to probe the performance, diagnose the issues, ensure the quality, and monitor the SLA to satisfy the customer requirements. Often, detection of service interruptions is challenging due to a lack of mechanism to sense service degradation and broken services. Anuta Atom is a composite network automation solution that is capable not only of detecting service degradation, but also capable of monitoring, alerting, and taking remedial actions as and when required. Atom ASA test suite consists of test agents and a test server. The test controller is placed at a central location where it can be on an on-prem server, virtual, or can be deployed on a bare metal server as well on the cloud. The test controller is responsible for signaling the initiation and termination of the test being conducted by agents. Once the test is finished, the metrics of the test are evaluated and the result is displayed to the user. More analytics and insights can also be generated out of these test results with the flexibility to run multiple tests in parallel at a time. Now let's proceed to run a few of these tests to see how the active service assurance feature works in real time. For performing any assurance test from Atom, we will need to navigate to Assurance, Service Assurance, and then go to Active Assurance menu. Here you will find a wide range of tests that can be utilized by the user. For example, the HTTP test can be used to check the health of HTTP related services. The VoIP_UDP test can be run to check the status of any voice related services. TCP and UDP based tests can be utilized to check transport layer statistics. These tests can further be clubbed to create custom testing suites like the one shown here, 5G_slicing test suite. It contains various tests like DNS, HTTP ping, which can be run together. Now let's run a few of these tests. To run a test, we will first need to select the desired test. As soon as we click on the test, the previous test runs and statistics are shown to the user. Now we will click on the Run Instance button. After clicking on the Run button, this page shows the user a form which contains all the necessary fields required to run this test. Let us start filling this form. We will give the name of the test instance. The Run as Monitor checkbox can be selected in case we need to run this test in continuation. We can also raise alerts in case of any SLA breach or complete test failure. Once we click on the Run DNS Test flow, we can give the entities such as DNS server IP, the lookup name, query type, threshold, etc. I will key these fields in. We can also choose to set the threshold timeout for error seconds and the number of error seconds for a failed test. Next, let's fill the test agent parameters which we will use for this test. We have deployed a remote agent which we will use to test DNS query times. We will provide the agent information in this form and the interface from where traffic will be generated along with the tags. Once this is done, we'll click on the Run. We can see the test has finished successfully now. We can also verify the error seconds or severe error seconds through this graph that is generated for this test. As we can verify, the SLA is not breached, which means the test withheld all the parameters that we provided in the threshold settings. These graphs can further also be downloaded for offline analysis in multiple file formats such as CSV, PDF, etc. Now let's progress to run another test. We will be using the ICMP ping packets to check for reachability between two sites. Similar to the last test, we will need to provide the instance name first. Next, we'll click on the workflow for the test, provide the test inputs, such as the test name, the source for generating ICMP request, the delay and deviation thresholds, etc. There is also option to set DNF flag which is right below the test inputs. After this, we'll provide the destination IP and the interface where the ping packets will be received. Once we have verified all the test inputs are correct, we will proceed to run the test. Each test can also be tracked from the Atom task viewer. Let's click on the test instance to see if we have started receiving the test data. We can verify the overall SLA is pass and the ES bar shows no error second or severe error second, which are denoted by red and orange blocks. We can also track the received packets, delay and jitter metrics from the below graph. As we can see, the delay is well within the set threshold, and similar is the case for the deviation. We can also verify that all packets have been received back from the destination IP. Upon refreshing the test now, we will observe that the test status is passed since none of the SLA was breached, and the same can be verified in the test results window as well. Now let's progress to run the next test, which is the TCP test. Atom provides users flexibility to store their test inputs and create test templates. These templates are useful for standardization of any of the tests and can be run at the single click of a button. Here we have created a TCP test template which uses one-directional TCP upstream traffic to measure the bandwidth between our local client and the TCP server. We will run this template now. As soon as we click on the template, we can see the results of the previous template runs. We can click on the run button at the top to verify the inputs of the template. So once the run button is pressed, Atom shows us the test template form. We have also checked the raise alert buttons for generating alerts on SLA and test failure. Now, if I click on the TCP test flow, I can see that the inputs like the test name, server IP, the TCP server port, and time period for running the test is already preset. We have selected the direction of the TCP test as upstream and also set the severe threshold value, which is 75 kbps, and the upper severe threshold as 120 kbps. This essentially means that anything below 75 and above 120 kbps will turn out as red on the ES bar. In addition, the test fail criteria is set to 2 ES. The client for generating the traffic is also pre-filled. Let's start the template run now. So as soon as we click on the run, we can see that the new template instance has started and we can verify the same on the progress bar. We can also track the Atom task viewer to see if the new task has been inserted. After a few seconds, we will see that the data point of ES bar has started to populate. This means that we have started to get the SLA and test data. Let's click on the instance now to see the live bandwidth we are getting. So as soon as I click on the instance, I can see in the results window that the bandwidth is well below the severe error second metric of 75 kbps, which results in the red blocks over the ES bar. This will continuously keep on changing as the test progresses. Now what we can observe is that there are a few orange blocks on the ES bar indicating that the bandwidth was above the severe error second threshold, but below the ES threshold of 85 kbps. We can also see the data points we have collected for this test by clicking this button here. Now from the results window, we can clearly see that this test is bound to fail since we have generated more than 2 ES, and the SLA will be 0 since none of the ES block turned out to be green. Upon refreshing the results, we can verify that the test status is fail and the SLA is 0%. Let's take a quick look at the alerts now to visualize the alerts which are generated for this test. Once we navigate to the alerts window, we can observe that there are 2 alerts each for this TCP up template, SLA failure and TCP template test failure. Users can create automated actions or run manual jobs over the test alerts, such as open incidents on the ticketing systems using the closed loop automation feature. This will be covered in detail in the upcoming videos. With this, we have come to the end of today's video. We have learned how Atom Active Service Assurance tests can be run to gather critical network service data. Atom Service Assurance can also be utilized to ensure network performance and the service standards are adhered to. This ensures that critical SLAs are always maintained in the network and the overall user experience is enhanced. Thank you for joining. Please check the space for upcoming demos where we will learn more about other active assurance features and advanced tests. We will also understand how to use features such as test schedules